This video is over section 1.3, applications of linear equations in one variable. This first problem says use linear equations in one variable for problem solving. The problem is John and Michael work for a shipping company packaging boxes. Together, that's going to be important, they prepare 925 boxes for shipment. So before we even start, together would be John plus Michael equals 925 boxes. If Michael prepares 25 more boxes than John, that would mean Michael equals, I'm actually going to move that here. Michael equals John plus 25. How many boxes did each person prepare? So we are going to plug in J plus 25 for M over here. And that's going to make us have J plus 25 equals 925. And then we're going to solve for J. So 2J plus 25 equals 925. Subtract 25. And we have 2J equals 900. Divide by 2. And we've got J is equal to 450. Now that we know J, we can plug J into our equation for Michael. And that would be 450 plus 25. And so Michael equals 475. So to answer the question, Michael packaged 475 boxes and John 450 boxes. And we can see that 475 plus 450 gives us 925 total like we wanted. All right, the next problem says solve equations involving percents and rates. This one says Harris County has a sales tax rate of 8%. And we know that sales taxes add to the price of something. How much does Barbara's car cost before tax if the total cost of the car plus tax is $17,098.83? So let's make y equals the cost after tax. P would be the principal or the cost before tax. Oops. And R is going to be the tax or the rate. So we're going to use this equation y equals P times 1 plus R. And so if we plug in what we know, we're going to have $17,098.83 equals P. We don't know what the original price was. 1 plus, to make 8% into a rate, it's going to be 0.08. And then we're going to solve for P. So $17,098.83 is equal to 1.08p. Divide by 1.08. And we have P equals, this is money, $15,832.25. And this would be the cost of car pre-tax. All right, the last one says solving equations using simple interest. This one says Melissa invested money in 2 accounts, one paying 5% simple interest and the other paying 4% simple interest. And interest makes the accounts grow, so we know we're going to be adding. It says she invested $3,500 more in the 5% account than the 4% account. If she received $940 in interest at the end of year 1, how much did she receive in each account? So let's use some variables here. Let's make L the larger account. And let's make S the smaller account. And we know that the larger account has a 5% rate and the smaller account has a 4% rate. We know, off to the side, we know that the larger account is equal to the smaller account plus 3,500. We know also that $940 in interest is going to be found by taking 5% of the larger account plus 4% of the smaller account, and that is equal to 940. Now we don't know how much money she put into the larger or smaller account, but we know that S plus 3,500 could be substituted for L here. And so when we do that, we've got 0.05 times S plus 3,500 plus 0.04S equals 940. I maybe wouldn't have used S. It's kind of hard to tell the difference between my S's and my 5s, but I'll be careful. I'm going to distribute that 0.05, and that gives me 0.05S plus 175 plus 0.04S equals 940. I'm going to combine my S's, and that's going to be 0.09S plus 175 equals 940. I'm kind of running out of space, but I'll try to write small. I'm going to subtract 175 on both sides, and that gives me 0.09S is equal to 765. Last, I'm going to divide by 0.09. And off to the side, that gives me S equals 8,500. I'm going to double check that in my calculator. Yeah. Okay, so we know S equals 8,500, and we can take that and plug it into our equation for L. So L is equal to 8,500 plus 3,500. And so the larger account is 12,000. So the question was, how much did she invest in each account? She invested $12,000 into the 5% account. And she invested $8,500 into the 4% account. And it didn't really ask, but total, this would be $20,500 invested total.